Fundamentally, MATLAB is an overgrown calculator. If you go to the command window, you can start typing in some basic operations, and you get the results back right away. You have the expected arithmetic operators for addition, subtraction, multiplication, division, and raising to a power. Evaluation of a compound expression is generally from left to right, but operators can have different priority levels. So, for example, multiplication is done before addition. You can use parentheses to give explicit grouping. By default, MATLAB represents all numbers in double precision floating point. You'd need to learn some numerical analysis or scientific computing to fully understand what that means, but it is the most common kind of computational simulation of the real numbers in science and engineering. You can essentially imagine that every value is represented in scientific notation with about 16 significant digits. MATLAB carries around all those digits in every operation, even though it doesn't display them by default. For example, if I ask for the square root of 2, we'll see just 5 significant digits. We can see all of the digits by using a format command. I'll leave the long format on for the remainder of this demo, as it's a good reminder of what's really happening on the inside. Speaking of scientific notation, when a result is much larger or smaller than 1, it may be displayed that way, with a lowercase e denoting the power of 10. You can enter a number using the same format, and that's preferable to actually typing in multiplication by 10 raised to a power. Okay, you've seen the square root function already. All the trig functions you know and love are here too. They expect their arguments to be given in radians, not degrees. Notice that the constant pi is predefined. The natural exponential, the base e exponential, is given by the function exp. Note that the constant e is not predefined. If you need it, you have to compute exp of 1. The natural logarithm is given by log, L-O-G, not ln. This is actually standard usage in mathematics beyond high school. To get a logarithm in base 10, use log 10 all as one word. Let me close this demo with some values that are not strictly numerical. First of all, we have positive and negative infinity. These pretty much behave and interact with numbers as you would expect, given a little bit of thought about what ought to happen. But if you do an operation that's indeterminate in the sense of calculus, like 0 over 0 or infinity minus infinity, you get a special nan result. Nan stands for not a number. This value has two major uses. You've just seen one. It's the result of an arithmetic operation that is not well defined. The other use for nan is as a placeholder for a data value that is missing for some reason. Generally speaking, operations that involve nans produce nothing but more nans. That does it for the most basic operations. In the next video, I'll show how to use variables to name values.